Okay, wait. Okay, today for the class, okay, I will show a little bit, okay, how you want to process using the data editor, okay, in the SurveyCAD. Okay, it doesn't matter if you don't have that uh, SurveyCAD. Okay, so maybe later on, you can get, or okay, or it's up to you. You can do by manual, okay. So ataupun you guna lips yang sedia ada, tiada masalah. Okay, but this one as a part of how you want to process, okay, compared to the CDS, okay, what the CDS provide, and then what in the SurveyCAD, okay. So okay, wait. Okay, so before I show for the, okay, in the AutoCAD, okay, so let me refresh, okay, a little bit before, okay, we have because this one as the last class for the engineering, okay, other than that, you will have a class with your own lecture that handle for your lecture class. Okay, okay, as I mentioned before this, okay, for before you process your data, okay, before you process your data, okay, so you need to think what is the horizontal control, okay. So as a surveyor, right, as a surveyor, the three things data that you need to provide, okay, to the client, basically the x, y, and z. Okay, x, y in term of the position, and then z about the elevation, okay. So SY, okay. So SY, okay. The question, okay, how you provide the SY, okay. That is by using the horizontal control. You apply by using the traverse, okay. So you will carry out the traverse in order you want to provide the position data, okay. So the question, how you start the traverse, you have a non-point. Okay, so that is a non-point that you need to use, okay, for the traversing. And then how you do for the adjustment, okay, because in your data, okay, so you will have the main traverse and the radiation line, okay. Last class for the engineering, okay. Other than that, you will have a class with your own. Sekejap ada that handle for your okay. So in the traverse data, okay, so in the traverse data, you will have a main traverse and the radiation line. Okay, so the question, how you want to, okay, how you want to do for the adjustment. Okay, so how you want to do for the adjustment. Okay, so in the adjustment, you will apply the C correction. Okay, so you will apply the C correction. Before you have a C correction, you need to know how to write the C correction statement. Okay, so this is the C correction statement. Okay, so important before you apply the C correction. And then, okay, and then how you want to apply, okay, the C correction in the line. Okay, so is it you want to apply in the line datum? Okay, the first line. Okay, if you look this data, okay, this sample data, sample field book. Okay, so datum line should be only have a M correction, okay, without C. Okay, so the C correction will start on the others line. Okay, but on the others line you need to look whether, okay, example here 2 to 5. Okay, 2 to 5, whether 5 is represent as your traverse, okay, as your main traverse. Okay, if 5 represent as your radiation, 2 to 5, 5 represent as a BKL, boundary mark. So meaning 2 to 5, okay, maybe radiation line. Okay, and then you look on the others line, 2 to 4 example, okay. 2 to 4, 4 is a traverse, so means 2 to 4 is the first line you need to apply for the C correction. Okay, so that is how you apply for the correction. Okay, and then okay, so that is about C correction. And then for the radiation line, okay, for the radiation line, you will apply, okay, with the M, okay, M correction. Okay, example here, okay, so you can see if we have a radiation. Okay, example okay, dekat sini 10 ke 12 10 ke 12, okay, kita apply sebagai M. So M tu kita rujuk pada bacaan 9 ke 10. Okay, 9 ke 10. Okay, so that is how you want to apply for the radiation line. So that you need to clear first before, okay, you will have the final bearing. Okay, you will have the final bearing and then you will have a final distance. Okay, final bearing and final distance you will use, okay, in your Stadia data. Okay, so you will use in your Stadia data. Okay, other than that, okay, so this one, okay, another important things, okay, how you transfer the data, okay, how you want to transfer for the vertical control. Okay, so vertical control. So in the measurement, okay, the first thing you will do the leveling. Okay, nowadays they will use a GPS. Okay, when you go to industry, okay, sometimes you will have an approach how to use a GPS in order to transfer the elevation. In UITM, a student will apply as a leveling. Okay, so from the benchmark, okay, transfer to the TBM, okay, and then go back to the and any non-point, okay, as a benchmark or SBM to close for the leveling work. Okay, so from the TBM, okay, how you want to relate with your traverse. Okay, example, okay, example here is your traverse. Okay, example, RLA is your traverse. Okay, RLB is your TBM. Okay, so now how you want to transfer from the TBM, RLB to RLA? So you need to have a reverse method. Okay, reverse method. So here you want to know about the RLB. Okay, so this one example when you do details, okay, you pick up the details and then how you want to transfer to the RLB. Now you have a from TBM at RLB, you want to know RLA. So meaning the first, as a student, you need to sketch. Okay, so you need to know how to sketch. Here, example, the vertical angle, okay, from RLA is less than 90 degrees. Okay, that's why, okay, observe outward. Okay, if the from the RLA to RLB more than 90 degrees for the vertical means, okay, so it will downward. Okay, when downward, so okay, so that you need to generate, okay, the formula. Okay, how you want to generate the formula, because okay, you will have different in term of the V. Okay, now example you have a RLB, you want to know the RLA, so RLB plus height target, then you minus with the V. Okay, then you bring to RLA, you minus with the height instrument, then you get the RLA. Okay, but if your observation downward, meaning from station A to B more than 90 degrees for the vertical circle. Okay, so meaning RLB plus height target plus V, then here you minus with the height instrument, then you will get the RLA. Okay, so that's why in the general formula you will look plus minus for the V, vertical distance. Okay, for the vertical distance it will be plus minus. Okay. Okay, once you transfer to your station, okay, once you transfer to your station, okay, so now you transfer from one station to another station, okay, by using the vertical angle and slope distance that you already record. Okay, where you already record. Okay, example, we look back to the field book. Okay, in the engineering. Okay, so in the engineering, you will have the vertical angle. This one, distance represent as a slope distance. Okay, so once you have the RL example at station number 2, okay, the other station you can calculate, you can transfer directly. Okay, because you already have the vertical angle and the slope distance. Okay, so why the important of you have the coordinate and the elevation, student? Why the important of you have the coordinate and the elevation in the engineering?
Know the height of every station.
Hmm?
To know the height of every station.
Okay, other than that, one that you can know. Okay, from the here the field book, you can directly transfer the coordinate and the elevation to the other point. Then what you can do with that coordinate and the elevation data?
Easy to plan for project. So we can plan for project.
Okay, actually you want to transfer to all your details, and so once you already have the horizontal and vertical control, then you will proceed with the details. Okay, you will proceed with the detail. Okay, example here. Okay, so station. Okay, at this station you already have the position and the elevation. So now you want to transfer to the lamp post. You want to transfer to the route. Okay, to the pond example. Okay, and then the other features that you have. Okay, so that is what actually you want to use the coordinate and the elevation. Okay. Okay, wait. Okay, example previous. Okay, so previous I show in the CDS. Okay, so for today, I will show how you want to use for the data editor. Okay, so the data editor, okay, you can get from the drop down menu, okay, here, or you can get from the okay, from the toolbar. Okay, so from the toolbar, you can click at here. Okay, here, data editor. Okay, so it doesn't matter for those who are not have the SurveyCAD. Okay, so you can look, at least you can look how the data, okay, will be processed using the SurveyCAD. Okay, and then you can look, okay, how you process the CDS and then compare to the data editor in the SurveyCAD. Okay, now, okay, I will open the data editor. Okay. Okay, so from the data editor, okay, so same thing with the CDS, you can import the data. Okay, so it can import the data. Okay, open project. Okay, so example here, okay, so see this. Okay, so I take this one. Okay, the SurveyCAD file. Okay, and then I open. Okay. Okay, so the same thing in the CDS. Once you have the data, the Stadia data that you import to the software that you want to process, okay, so the first thing you need to, what you need to do, plus, once you have the Stadia data like this. Okay, so you will insert the non-point. Okay, so you will insert the non-point because in the processing, okay, in the processing, what you have declared here, example station number 1 and station number 2. Okay, what is the coordinate? Okay, what is the elevation? Okay, so what you can do, you can type insert, or okay, here you can go to edit and then insert the coordinate. Okay, you insert the coordinate. Okay, so now I will show how you want to process this data. Okay. Saya akan masukkan dulu. Okay, data XYZ saya akan masukkan dulu. Okay, so this data you get from your observation. Okay, from your final bearing, final distance from the field book. Okay, and then from the vertical control, okay, for the elevation. Okay, so the same thing. Okay, how you want to key in? Okay, in the CDS. Okay, so the first thing you need to declare the coordinate. Okay, maybe some of you already know. Okay, already well know about this, but okay, I know. Okay, most of you will not know. Okay, what actually the process that you have done, okay, from the traversing you have done, from the leveling, okay, how you want to relate with your processing. Hmm. Okay, wait. Okay, so now example, okay, I declare a few station here, and then we try to calculate, we try to calculate in the CDS also. You need to calculate the coordinate. Okay, so you need to calculate the coordinate. Okay, so here if you declare, okay, it's not enough of the station that you use. Okay, so it will appear like this. Okay, station backside 8 has no coordinate. Okay, so meaning you need to key in, okay, for the coordinate of number 8, okay, and the other station if you have a few station. Okay, for example, I try to check first. Okay, wait. This one now. Kat mana ni? Sweden. So now until station 7. Station 7. Okay, so saya key in silap ada data silap. Okay, so all of you wait for a while while I key in this data.
Pergi kamar. Kamar.
Okay, so once we already complete, okay, for the station, okay, the coordinate and elevation. So we try to, okay, so we try to compute, right? We compute the coordinate. Okay, so now you can see when complete, okay, so you can, okay, so you can process the data, okay, the calculation complete. If not, you will ask about the station that you not declare for the coordinate and elevation. Okay, so now, okay, you will in the CDS you will store in database, okay, and then you need to export. Then you go to the main menu, then you want to export to the DWG. Okay, for here you can go to the tool and view in AutoCAD. Okay, so you will be asked for the separate layer by code, yes or no. Okay, if you separate by you yes, okay, you will create a few. Example GL one layer, 3 one layer, but we need to use a no. Okay, what happened? Okay. Okay, so here with a data. Pula. Okay, pula. Okay, try to close and open again. Okay, data complete. Then separate layer by code. No. Okay, okay, sekejap Sekejap, saya cek. Okay, sebagai contoh bila data dah keluar, okay, once you can open the data, okay, so what you will do with the data, so you can type RBKL, R station. Okay, so R station. Okay, so it will remark the station point. Okay, so this one, the first thing that you need to check. Okay, example, your data study is already open. Okay, so you want to check whether the data of the traverse, okay, in the orientation or not follow the orientation or have a mistake. Okay, so you can type RSTN. Okay, RSTN. Okay. Okay, so it will appear the number of the station like this. Okay, so it will appear the number of station like this, so you can check, okay, whether, okay, this one follow or not, okay, the orientation of your traversing. Okay, so now we try to hide the data. Okay, dekat sini sepatutnya kan dia keluar, dia akan ada ni lah. Okay, point code and height. Okay, so here you can check, okay, your data. Example, you have a data before you generate the contour, and before you generate the contour, okay, what you need to do, okay, you can go to the SurveyCAD earthwork, then you go to the height analysis. Okay, so height analysis, okay, you can select all the point, okay, and then you can check. Okay, so what something wrong with this data? Okay, cannot represent about the heighting data. Okay, so actually once you select the data, okay, it will show the lowest and height of the height. Okay, so daripada sini you boleh tengok, okay, data ketinggian, okay, daripada rendah hingga yang tinggi, and then you can set for the interval for the contour. Okay, interval for the contour. Okay, in order you want to generate the contour, okay, you can go to the SurveyCAD and contour auto contour. Okay, so now what I want to show, okay, if you have a data like this, okay, from the CDS or SurveyCAD, okay, you need to join the data. Okay, so you need to join the data in here. You can use a by a join code. Okay, join code. Example, example, we want to join for the okay. Okay, so before that, we try to show for the symbol. Okay, symbol. Example here, you can customize. Okay, if default, you can use all this default. Okay, you just select and then you accept. Okay, so automatic it will show where the your tree, okay, automatic with the symbol of the tree. Okay, so this one you can customize where is the TL, TT. Okay, so if not, you don't have this SurveyCAD, so you need to do manual. Okay, in AutoCAD you do manual the symbol and then you copy paste to the others point. Okay, if you use the SurveyCAD automatic, it will generate to all the point, okay, that have a same code. Okay, then you want to join the data. Okay, you want to join the data, example here. Okay, so example here, you can join the data of this one. First. Okay, next. Okay. Okay, it will join the data. Okay. Or you can use a JCC join code. Okay. So you can see. Right. So it will join. Okay, the same code, but this one Okay, so you need to do editing. Okay, so you need to do editing. So we don't want like this. Okay, so we don't want like this. Okay, what you need to do, you need to do editing. Okay. Okay, so that's why you need to know. Okay, okay, as a drafter. Okay, so you need to know how to. Okay, so semua ni you kena buat editing balik supaya dia jadi masuk balik seperti yang dikehendaki. Okay, so anyway you can do by one by one. Okay. Okay, so that okay, you need to join. Okay, so you can join for the data. So I just want to show. Okay, I don't want to show all. I just want to show the menu that you can use in the SurveyCAD in order to you to prepare for the detailed plan. Okay, then you want to show for the TBM. Example, you want to show for the TBM. Okay, you click TBM and then example your point TBM. Okay, at here. Okay, contohlah dekat sini. And dekat sini you punya point. Okay, so you boleh tunjukkan. Okay, so dia akan keluar dengan coordinate with the elevation. Okay, so this one I don't know what happened to my data. The heighting is not appear. Okay, so I will check. Okay, then for the building, example building. Okay, building. Okay, here. So what you can do? Okay, so you can hash the building. Okay, so you can hash the building and then you put the label. Okay, so you can put the label. Okay, all the building you will do the same thing. You join the code and then you hash, and on the center you label. Okay, so you need to label. Okay, so this one symbol. Then I need to show. Okay. Okay, contoh you dah siap. Okay, so you dah siap join details. Okay, yang ni saya tak tunjuk lah. Okay, so bila you dah siap, so you akan insert you punya frame. Okay. Insert frame saya. Insert frame for details. Okay. Okay, so this one example. Okay, this size of frame is not fit. Okay, to your data. So what you will do, you will scale. Okay, so you will scale the frame. Okay, if not, you can start for on the starting. Okay, you set the frame size. Okay, example like that. Okay, terus Okay, so for you want to start, okay, so you can set, okay, your paper size A3 example, and then scale. Okay, if a manual, okay, so manual you need to, okay, so if a manual you need to know how the dimension. Okay, once you create that drawing, the frame, okay, so you need to look to your data. Okay, so you need to look to your data whether it fits to your data or not. Okay, so you kena tengok boleh masuk tak data dengan you punya, okay, you punya frame. Okay, so kalau tak boleh you kena scale kan dia. Okay, so you kena ubah lah scale dia. Okay, scale object, okay, base point, okay, and then contoh you letak berapa, letak 2. Okay, so dia akan lagi besar. Okay, tadi 1/1000. Okay, so now 1 ratio to the 2000. Okay, and then you will look whether it fits to your data or not. Okay, no. Okay, so meaning you need to, okay, you need to scale again, okay, to make sure, okay, so it can fit to your data. Okay, contoh, and then you move, okay, so it will fit to your data, but I think it's too big, okay, for the frame, so you need to adjust, okay, for the frame. Okay, so the point is once you want to process the data of the stadia, okay, so you need to know about the non-point and the elevation of the station. Okay, so make sure your field book, okay, you apply the correction is correct, okay, before you have a final bearing, final distance, then you will use in order to calculate the coordinate. That coordinate you will use in the stadia. Okay, so after you already process to the AutoCAD, so the task is you need to do the editing. You join the code, the same code, okay, where the tree or features as a point. So you need to show the symbol, okay, symbol of the tree, symbol of the apa ni, slope, okay, slope top and bottom, okay. So then once you have finished, okay, edit for your data, just you insert the frame, okay. So just you insert the frame, then it will fit to your data. Okay, so many option here, okay, so you can do, you can process, okay. Here example, you want to once you have your data in the traversing, you can export your data, okay, to the CSV format. Okay, it will appear in the Excel, okay, in the comma delimited format. Okay, so this format will, okay, you can change which one that you want. Okay, so this one in terms of the purpose of the report, you want to provide the report. Okay, or you have a example, you have a data XYZ, okay, and then you want to import in the CAD software, okay, you can use in the import, okay, import XYZ data. Okay, so others in terms of join code and, okay, in terms of you want to show for the symbol, all have in the CAD, okay, in the SurveyCAD. So you can use, you can explore, okay, from time to time, okay, in order you want to prepare for the final plan. Okay, your project will be detailed plan. Okay, detail and maybe in topography. Okay, so depend on the data that you have get. Okay, and then you try to look what is the output that you need to show in the final plan. Okay, so any question?
Sir,
Ha,
untuk yang koordinat tu tak apa ke kalau kita tak ikut rutan macam Sir buat tadi tu? Ke
tak
tak
ada
apa?
tak ada masalah. Okay, tak ada masalah.
Okey. Okey.
Okay, form kehadiran saya telah letak dekat chat room, so you